My name is Meng Shiyao. I'm from Harbin Institute of Technology. I'm glad to share my paper about intersatellite link interference detection and analysis on NGSO satellite system. The article describes the main contents of our work from 4 parts, including motivation of our work, interference calculation, other interference, and simulation result and conclusion. So, firstly, let me introduce motivation of our work. In NGSO satellite communication, an important situation that may produce interference is the interferencing of intersatellite link. A satellite in NGSO constellation will be subject to a variety of potential interference signals. It is mainly divided into uplink and downlink signals. For the communication between constellation A and Earth station A in the figure, the interference in the uplink is mainly the interference from satellites of other constellations and other possible stations. The main interference is the downlink is divided into the interference of other constellation to the Earth station and the possible interference of GSO constellation to the Earth station. In the discussion of intersatellite interference signals, the adjacent satellite interference signals are generally considered. In this problem, we mainly consider the interference of the uplink channel in the satellite adjacent system. In other words, the actual useful signal in the system of the process of satellite communication is the useful signal strength sent by the ground station, while the interference is caused by the information sent by other constellations. However, in some signals, when the local satellite A exchanges information with the local Earth station, the output information of the neighborhood satellite B may also be transmitted to the receiver of the local station satellite A, causing direct interference between the two stars. It can be seen that this situation will occur in the uplink state of the main link. So, it's necessary to consider the interference of signals emitted by other non-geostationary satellites and the interference caused by some geostationary satellites. Then is about the interference calculation. No matter what kind of intersatellite interference is caused, the same data processing method can be used to quantify the interference and know whether it is necessary to adjust the system, such as adaptive power control. Then we needed to calculate the best sampling time of the system, which can reduce the amount of data calculation as much as possible on the premise of correctly judging the interference between the systems. The following formula is needed to calculate the optimal sampling time. And in the formula, there is the step size of the downlink time, the time required to interfere the main lobe radiation range of the antenna of NGSO satellite passing through the Earth station, and the sampling times of the main lobe radiation area of the receiving antenna in the ground station. According to the regulations of the International Telecommunication Union, as long as the influence of the interference signal from the adjacent satellite on the equivalent noise of the receiving systems of the satellite reaches 6%, it's generally recognized as that there is interference in the adjacent satellite system and needs to be adjusted. Therefore, 6% is regarded as the threshold. If the relative increment of equivalent noise temperature can be expressed as the first formula. So, the relationship between the SINR ratio of the final transmission and the CNR ratio transmitted by the intersatellite link itself is as the second one. And here are some used formulas about the downlink carrier to interference ratio. Considering the system margin, M can get the formula according to the threshold calculated. The carrier to interference ratio threshold will be 15.2 dB higher than the system's owner carrier to noise ratio. So then, according to the ITU RS1324, the overall algorithm processing is shown in the table. And there are many kinds of interference and environmental factors in the satellite communication system. One, considering the interference between satellites. The free space transmission model is generally considered, and the atmospheric loss and rain loss are also considered. Then is the simulation result and conclusion. We need to classify each group of data, extract the data according to the interference situation, then select the appropriate system parameters for various interference situations, and design and calculate the relationship between intersatellite interference and its influencing factors. Considering different interference scenarios, Constant theorem is used to calculate various angles to obtain gain of different angles, and finally, interference situation is obtained, as is shown in the figure. The analysis of the judgment value shows that the interference of one web to Starlink system is slightly larger than that of Starlink to one web system. When the communication frequency is about 20 GHz, the rainfall attenuation is about 5 dB under the condition of light rain, with daily rainfall of about 5 to 10 mm. In Starlink system, the intersatellite interference may be caused at some time under the condition of rainfall, which may cause interference to NGSO communication system, but it is relatively small. The real-time data of LEO satellite systems obtained by communication system simulation can obtain the angel relationship, distance relationship, and current time of two independent systems at a certain time. At some time, there may be no signal transmission between the two satellites, and there is no interconnection, so the data will not be obtained at this time. When considering the interference between constellations, you can summarize the interference received by each star of a constellation over a period of time, and then record the received interference and which star from which constellation for statistics, so as to get the interference received by a constellation. After that, we need to classify each group of data, extract the data according to the interference situation, Then select the appropriate systems. The multi-dimensional analysis of interference and time and frequency shows that in the frequency range from 26 GHz to 40 GHz, in other words, in the range of Ku band, with the increase of frequency and free space loss, the final SNR of the system will decrease, and the possibility of interference will increase. As for the relationship between interference and time, with the change of time, the angle and distance between satellites will also change, and the final interference decision will be as follows. As is shown in the previous image, this is the interference feature of intersatellite data when considering the time distribution characteristics of intersatellite interference. A new reference standard is introduced, which is defined as the relative interference time. That is the ratio of the time that a system is affected by interference in one day to the total operation time of the system. In the adjacent satellite system, the longer the relative interference time is, the worse the environment is, and the system needs to be adjusted. So, in conclusion, aiming at the problem of complex electromagnetic space and difficult observation in NGSO large-scale satellite constellation system, we mainly studied the link characteristics of NGSO satellite constellation. Firstly, starting and one-wide constellation are taken as the research objects. According to the constellation parameters of LEO satellites, equivalent isotropic radiated power values are obtained and visualized. Then analyze the acquired NGSO electromagnetic satellite data. Obtain the data relationship between the attenuation characteristics of the data and the time and frequency. Then calculate the intersatellite link interference and its temporal distribution characteristics. The relative interference time and the multidimensional characteristics of intersatellite data attenuation and time frequency are obtained. The time characteristics of interference in different signals are analyzed. The interference of intersatellite links between NGSO large-scale satellite constellation system is analyzed from multiple dimensional and verified by simulation. Finally, it's proved that there is interference in the intersatellite link between NGSO large-scale satellite constellation systems. And the higher the frequencies, the more obvious the interference phenomenon. That's all. Thank you for your listening.